Hi dear student, today I will go for the one of the next concept in the D block element chapter. What is the D block element? In that next chapter continuation concept is a trend in atomic radii as well as metallic property, or go for the melting point also. Metallic property as well as a melting point also. Now in this D block element, what is the changes in how the character will be changes? For example, atomic radii, we know that scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, and next zinc. These are the D block element. In these D block elements, how this metallic property, for example, atomic radius increases or decreases. The next one, go for the next one, yttrium to cadmium, next lanthanum to next one is cadmium, next one is mercury. How this metallic, for example, they are called as 3D series, they are called as 4D series, they are called as 5D series. How this melting point, how this atomic radius changes in the along the groups as well as we have to go for the along the period. That is very, now we have to discuss in the D block element chapter. In this D block element chapter, what happens to this atomic radii? First, we'll go for the one simplest concept. In past PUC, we learned that chemical classification of element. How this atomic radii changes? Atomic radii, it's very simple, dear students. You see here. First, go for the left to right. Left to right, what happens? The atomic radii means this is what atomic radii. Atomic radii decreases. Atomic radii decreases, and top to bottom atomic radii increases. Atomic radii, what happens? Increases. Here decreases, and here it what happens? Decreases. Why this is atomic radii? In general, periodic table, go for the any periodic table elements classification. In the atomic radii, first left to right, what happens? Left to right decreases, and top to bottom increases. Why it is happening? I will tell you first. After that, I will go for the D block element concept. In that, what happens? In D block element, in left to right atomic radii will be decreases, because, for example, you go for scandium. Go for the scandium. Scandium to next one will be zinc. The electrons will be enter. For example, in this electron enter in 3D. Next 3D1, 3D2, 3D3, next 3D3, like that it continuously end into 3D10. Here what happens? Electrons enter in the same shell. Electrons enter into the same shell. For example, this is what, assume that this is what a 3D shell. In this 3D shell, the electrons enter into the same shell. If the electrons enter into the same shell, then there will be more force of attraction between the nucleus and electron will be more. Therefore, there what happens? The atomic size becomes contractions. The number of electrons enter in the same shell. Therefore, electrostatic force of attraction increases. Here what happens? The protons and electron force of attraction will be increases. If before first 1 electron, 2 electron, 3 electron, like this, number of electron increases, the force of attraction increases. That's why in left to right, what happens? Electron enter to the same shell. The force of attraction between the nucleus and electron more. Therefore, size will be decreases, dear students. It's very simplest concept. Next, what happens from top to bottom? From top to bottom, for example, you go for top to bottom. Electron center here 3D shell. Here it will be 3D shell. Next, go for the 4D shell. Therefore, the electrons enter into the different shell. The size will be increases. Therefore, there will be less force of attraction. Here 3D, here 4D. The force of attraction will be more. Therefore, from top to bottom, atomic radius will be increases. Okay. Go for our 3D series element. Go for our D block element. The same concept. This is what elements in left to right in the periodic table. Therefore, from scandium to zinc. From scandium to zinc, what happens? This is a larger size. Next, size of the element will be decreases. Size of the element will be decreases continuously, because the electrons enter into the same shell. All valence electrons enter into the 3D block element. In the 3D series only, their electrons enter. Therefore, the atomic size will be decreases, because electrons enter into the same shell. From top to bottom, for example, it is 3D. Next one 4D. Next one is 5D. Therefore, number of K shell, L shell, M shell. Therefore, number of shell increases. The atomic radii will be increases from top to bottom. In one thing I will tell you. This here in your NCERT textbook, they are given one chart, one graphical representation. What they are given? What is that? You see here. This is what a transition element. For example, this is what is transition element or d block element. A d block elements. Because here what happens? Atomic radii, atomic size, atomic size. What they are, this from examples, scandium to next zinc. From scandium to zinc, what happens? Atomic size first they are very less. Therefore, first atomic size will be like this. Atomic size will be like this. It will be continuously decreases and it will comes to. Next, go for the next ytterbium to cadmium. Ytterbium to cadmium, what happens? Some of the atomic radius increases, and here what happens? The continuous atomic radius. Next, go for the lanthanum. Lanthanum to mercury. Lanthanum to mercury, what happens? The atomic radius will be continuing. Here you see here, here atomic size. You see here the atomic size here nearly same, but here also atomic size will be nearly same. This is what 3D series, and this is 4D series, and this is 5D series. Here 3D series, 4D series, atomic radii, for example, this atomic radii nearly same, same atomic radii, because in this, why this is the same atomic radii? Because there will be F block element. F block elements will be comes. F block element. This F block element shows same atomic radii. These F block elements are shows the same atomic radii. That's why these F block element, why they are showing same atomic radii? They are showing same atomic radii because of only one reason. They are showing same atomic radii because of due to lanthanoid contraction. Lanthanoid as well as actinides also. Lanthanoid and actinoid contraction. Due to this, here what happens? 4D and 5D series element, thereby lanthanide actinoid elements will come. That's why these elements are shows nearly same atomic radii. But in 3D series there is no any exception. Therefore, atomic radii continuously decreases. And next there will be again atomic radii will be same because there will be lanthanoid elements. That is one exception in 3D and D block elements, dear students. Other than that, left to right atomic radius same use usually atomic radius will be decreases, top to bottom will be increases. What is this lanthanide as well as actinoid contraction? This lanthanide and actinoid contractions I will discuss in the F block element chapter separate. It is there in the syllabus. Okay, just you have to remember this, their atomic radii is nearly same because of due to lanthanide and actinoid contraction. That's important. Okay, this is what atomic radii concept. Next to go for the metallic property.